Hello class, this is a quick video on chapter 13, practice questions. We're talking about solutions, molality, molarity, density, mole fractions, mass percents. These are the questions I'm going to talk about per se. Let's get going. Take a moment and copy these down. These are the key equations that we need to know. Keep this next to you. It's easy to check back and forth between what we're going to have and what we're looking for from this list. So question number one, let's find 39% H3PO4 aqueous with water by mass. And by mass, what we assume always is 100 grams total. So if we have 100 grams total, 39% would be 39 grams plus our unknown grams of water. That will equal 100 grams. And the question is, well, how do we know 100 grams? Well, we could assume a different mass and then recalculate the percent of 39%, or we could just assume 100% is 100 grams total. That way it's easy to calculate the mass of the solvent, H2O. So X grams of H2O equals 61 grams, which tells us that of the total solution, 39% is H3PO4. 61% is water. That's how we use mass percent. Okay. The mole fraction is 7.2% HCl. Well, let's go back to our original solute plus the solvent is the solution. So the solute, well, that's like HCl solid plus our solvent, that's H2O. That's going to yield HCl aqueous with water at a certain concentration of HCl in it. So that's where we get this formula. And if we assume 100 grams, 7.2 grams, there we go. Remember, we assume that. We assume this to be 100 grams, so the math is easier. So we calculate 92.8 grams of H2O. So what we're looking for is the mole fraction of this solution. So let's convert our grams to moles. We have 7.2 grams of HCl, and we have 36 grams in 1 mole. That gives us 0.2 moles of HCl. We have 92.8 grams. Just reminding you, this I'm dividing by the molar mass. If I add both these together, my total moles is going to be 5.36 moles of the solution. I added my moles of HCl plus my moles from water to get the moles of the solution. And then, if I come up here, my mole fraction is going to be the fraction of my solute, 0.2 moles, divided by the total moles, 5.36 moles, and that's going to equal 0.037. And that number is unit list. Excellent. So, find the molality from 27% mass of nitric acid. Well, again, let's do our original, because we're talking about by mass, let's assume 100 grams. So 27 grams plus X grams of H2O. It's going to equal 100 grams of the solution. X grams will be equal 73 grams of water. Now let's convert our solute to moles, because we're looking for molality. So 27 grams divided by 63 grams per 1 mole. So it's going to give us 0.429 moles. And this is HNO3. Let's rename that. This is the moles of the solute. Remember what's going to be dissolved. If I look back, I have 73 grams of H2O. Well, that also equals 0.073 kilograms of H2O. Remember my equation for molality? It's the moles of the solute divided by the kilograms of the solvent. Molality is 5.87. Abbreviated little m, I don't like using that because I think of meters or moles and it doesn't make any sense to me, but that's what molality, that's how we find molality from a given by mass. Excellent. Find the percent mass of a solute in this equation. Now I already, so we calculated our solute here plus our solvent for our total grams of solution. And we're looking for the percent of mass. Well, percent of mass is the mass percent. So mass of the solute, 27.7 grams, divided by the total mass, 402.7 grams, times 100%. Cool. So 6.75% CaCl2. Moving right along, finding the molality from the percent of a solute. So given we have 13 grams plus X grams of solute, they're going to equal 100 grams total. Remember, that's the assumption that we make because it's a percent by mass. X grams is going to be equal to 87 grams. Now I'm looking for molality, so I'm looking for moles of the solute. So I'm going to convert 13 grams into moles using the molar mass of NaCl. That's going to give me 0.22 moles of NaCl. Now that's going to be divided by the kilograms of my solute. And I've calculated 87 grams. Well, that's also the same as saying 0.087 kilograms. It's going to give us 2.58 molality. And that's how we find the molality from the percent. So some common methods here that we've gone over. Assume 100% is 100 grams. That makes the percents easy. Therefore, my 13% is the same as 13 grams. Multiply that 13 grams of solute into moles and divide by the kilograms of the solvent. So this is a tough one. We're going to calculate the mass percent of a solute given a series of conditions. We have a molarity, we have a density, and we have the molar mass. One thing we need to remember is that the molarity and density work together. That's what we have. That's why we have both of them. It's very, very important that they work together. All right, so this is going to take some stoichiometry. You might have to come in and see me to talk about this like in more detail. So come see me at lunch or after school. I'm going to start off with the moles of our solute, NH4Cl. This is what 1.73 molarity looks like. It's 1.7 moles of our solute, NH4Cl, divided by 1 liter of solution. Now I'm going to convert that 1 liter, I'm going to convert the 1 liter of solution to 1,000 milliliters, because my density is given in milliliters. Now, remember, these units have to work across the fraction sign, the denominator. So, in 1 milliliter of solution, I have 1.0257 grams. Finally, I'm also going to, if we zoom back out here, I'm also stuck with moles. Let me highlight that. We're also stuck with these moles. So I'm going to use that molar ratio in this box. One mole of NH4Cl is worth 53.5 grams. So if I zoom out and I start canceling units, the moles that are over here, well, that'll cancel. It's liquid solution, milliliters. But then I have grams of both. Well, remember, this is where things get confusing. I have grams of the solution here, and I have grams of the solute, NH4Cl, there. So I can't cancel them. They're not the same thing. So I'm left with, if I multiply all my fractions across and divide, I'll be left with 92.55 grams of the solute, NH4Cl, divided by 1025.7 grams of the solution. Well, grams over grams is our mass percent. So I divide those two times by 100%, and I'll end up with 9.0% solute, NH4Cl. Whew. Okay, so this is definitely like a 5 out of 5 on difficulty. So come see me if you have questions here. We'll definitely talk about this one in class. Next, we want to calculate the molarity of a solution given the density. And remember, density and molarity work together. They're best friends. So if we zoom in here, here's our initial total solution. And I've calculated the total grams. So I'm going to start with the grams I'm given here. 15 grams of NH3 divide by my molar rate, my molar mass to get the number of moles, and that's going to give me 0.88 moles NH3. And I'm looking for the molarity. The molarity, I'll calculate over here. The molarity is between the total liters of the solution. And I have calculated the grams of solution by adding 15 plus 250 equals 265 grams of total solution. Well, we can use the density to calculate that grams into liters. And that's the unit I'm going to use for molarity. So the density is 0.974 grams per 1 milliliter. And then convert from milliliters to liters, 1,000 milliliters in 1 liter. That's going to give me 0.272 liters of the solution. So I have moles and I have liters. So let's use both of those to find molarity. It's going to give me about 3.24 molar. So just to recap, I converted, I started here, and I converted my assumed 15% grams into moles. Then using the density, I converted the total grams of solution into liters, and then divided the two, and that is molarity. Find the molality this time, given the similar constraints. Well, I already calculated the total grams of the solution. So first thing we do is convert this into moles. So 23.7 grams CaCl2. And 111 grams is equal to 1 mole. 0.2135 moles. Excellent. And I also now need to convert this right here into kilograms. 375 grams is equal to 0.375 kilograms. Molality is moles, 0.2135 divided by kilograms, 0.375. There we go. That equals 0.569 molality. Done. So just a quick recap. First we converted our solute into moles, then converted the solvent into kilograms, and then divided the two. And that's it. All right. Another really difficult one. Calculate the mass of a total solution. Here's our lithium chloride. I didn't know what that was, so I Googled it. That's the molar mass. And that's what it looks like. Lithium plus chloride. Here's our assumed 12.5% in 100 grams of solution. We got there. That's going to yield us 87.5 grams of solvent. But hold on there. Given in the question was given with 52.5 grams of the solvent. Question, what do we do now? Well, let's use a proportion. If 12.5 and 87.5, therefore X is equal to 52.5 grams. So my grams of solvent I use as the denominator, and the grams of the solute as the numerators. Cross multiply and divide, and X equals 7.5 grams. Remember, that's my solute, lithium chloride. But that's not what it's asking for. It's asking for the total number of grams of the solution. Well, I have the solvent here and the solute there, so if I add those two together, 7.5 plus 52.5, well, that equals 60 grams of the solution total. And there we go. If we want to double check, we could divide 7.5 by 60, multiply by 100, and we'll get 12.5 grams. So, that's all I've got. That's a lot of questions. It's a long video. Let me know if you have any questions.